In this video, I want to demonstrate 3 examples of where you're given 2 graphs, one of those being the graph of the basic function, one of those 7 basic functions, and then you're given a transformed graph, and you need to write what is the function for the transformed graph. So I have on this graph the basic graph of y is equal to the cube root of x. Recall some key points on that graph are 0, 0, 1, 1, negative 1, negative 1. Off my graph would be another point like 8, 2, or negative 8, negative 2. So these are the basic points. So what I need to do is try to identify corresponding points on the transformed graph so I can identify the movement that took place to get to those points. So notice on my transformed graph, I see the point negative 3, 0. It also goes through the point negative 2, 1. And it also goes through the point negative 4, negative 1. So when I compare the coordinates of these points, the y values are the same, right? The negative 1, 0, and 1 are the same. So there was only a change to the x, so that means my function will represent an inside change. And what was that change? Well, I had to go from negative 1 to negative 4, 0 to negative 3, 1 to negative 2. So what I noticed is that the x values decreased by 3, but the y values stayed the same. So that means my original function we know is f of x equals the cube root of x. So my transformed function g of x is going to be the cube root of x plus 3. Right, when we have a shift left of 3, that means we need to add a number to the inside expression. Now let's look at another example. On this graph we have the V-shaped graph and a transformation of that. So that V-shaped graph, hopefully you recognize as the absolute value of x. So our basic function is the absolute value of x. And we know that it goes through 0, 0, 1, 1, 2, 2, and so on. And then also negative 1, 1, and negative 2, 2. So we want to identify some of those corresponding points on this transformed graph. Always look at your vertex point, that is the lowest point. So on this blue graph, my lowest point is at 2, negative 1. Then we can identify 3, 0, and 4, 1. To the left of the 2, negative 1, we can see that it goes through 1, 0, and 0, 1. So note that both the x and y values change, so we need a way to designate an inside and an outside change. You can just think about this by comparing the vertices. So I went from 0, 0 to the point 2, negative 1. And so what had to happen? My x values were increased by 2, and my y values were decreased by 1. Let's just double check that that works for another one. So if I look at the point 1, 1, and going to 3, 0, my x value increased by 2, and my y value decreased by 1. So I need to write a function, g of x, that is a transformation that has a shifting right 2 and down 1. So to shift right, we're going to have a minus sign inside, so this would be the absolute value of x minus 2, and then the down 1 would be minus 1 on the outside. And now we have another one that is a transformation of absolute value of x again. We could use any of our basic functions with doing these exercises. So we know that f of x is the absolute value of x. We know key points on that graph: 0, 0, 1, 1, 2, 2, and negative 1, 1, and negative 2, 2. So let's look at points that are on the transformed graph. And just visually, hopefully you'll see that the blue graph, it is shifted right 2 units, but it's also flipped upside down. So there's going to be a reflection involved in this. So note that our vertex is a point 2, 0. Then we have the point 3, negative 1, and 4, negative 2, and then 1, negative 1, and 0, negative 2. So notice that 0, 0 shifted to 2, 0. 1, 1 shifted to 3, negative 1. 2, 2 shifted to 4, negative 2. So let's see what happens. We definitely see the shifting right 2. So our x values increase by 2 each of those times. And what about the y values? The y values, well, 0, 0 stayed the same, but we went from 1 to negative 1, 2 to negative 2. So the y values are opposite. And opposite y values are a reflection across the x-axis, but remember that is an outside change. So my function has to have an inside change to reflect that it's shifting right 2, and then an outside change to show the reflection. And so our function g of x will be written as the opposite of, and then in the absolute value, x minus 2. You could graph this on your calculator and make sure that that graph coincides with the graph that is shown here.